Hi everyone, we are continuing with some statistics questions again. So today we'll be doing January 2017, January 2020, and I don't know which one is here. Right, so the table below shows the number of bananas to the nearest ton produced annually on a farm over a period of 6 years. So remember, you want to take your time and read the question, read the information, and ensure that you are understanding what they are actually trying to analyze. Right, so on the graph paper provided on page 21, draw a bar chart to represent the data. One second, sorry. Right, so we're going to use the same. So they said on the graph provided on page 21, draw a bar chart to represent the data given. Right. In the table above, using a scale of 1 centimeter to represent 1 year on the x-axis and 1 centimeter to represent 25 tons on the y-axis. All right, yeah. Right, so what we're going to do is head up our graph. And as we know, you all should have your paper to do it as well, right? Now we are doing a bar chart. And the difference between a bar chart versus a histogram is that in a histogram, the bars are actually connected to each other, as we would have seen last class. Now in a bar chart, you make a bar, and then you leave out the space, and then you make another bar, and then you leave out the space, and then you make another bar, and you leave out the space, right? So histograms touch, bar charts don't. But it's the same thing. We put frequency, so make sure that's what they told us. 1 for 1 year. So year is on the y-axis. So this is year, and I always try to put your stuff, and that we have 1 to 1. Hold on. Draw a bar chart to represent data given in the table above using 1 centimeter to represent 1 on the x-axis. So down here is your year. 1 centimeter, remember 1 centimeter is 1 block, right? One of the blocks that has the 5 small blocks in them to represent 1 year. So year is down here. And every 1 centimeter we put a year. So we start at 2010. Then we leave a space with 1 block, 2011, then 2012, then 2013, 2014, and 2015. So we know that these are the blocks that are going to represent our years, and we leave 1 block in between them because our bar charts do not touch each other. And now on our x-axis, they said every 1 centimeter will represent 25 tons. So we're going here, and our first ton is 25, then 50, then 75, then 100, 125, 150, 175, 200, 225, 250. What's our highest number? 275, right? So we could go to 300, you know? Right, so now that we would have lined up and graphed and plotted our points on our axis, do we have any questions? So just remember to take your time. They say 1 year, 1 year, 1 centimeter to represent 1 year on the x-axis. So you take your time, but with a bar chart, you leave the space. And then 1 centimeter to represent 25 tons on the y-axis. So you go on the y-axis and you do your stuff, right? You do not need to leave spaces between your numbers going up on the y-axis, right? You leave your spaces between the bars on the x-axis. I hope that everyone is clear on that. So now we actually drop our bar chart, which we know how to do. The face 2010 goes up to 150, so we come here. Right, using your ruler, of course, making those bars nice and neat. Then 2011 goes up to 275, so we're here on 2011. Then 2012 goes to 100, so we're just right here on 2012. And continue that for me, please. So we continued and we finished off our bar chart. For the bar chart, they could also tell us to put our years here and our tons on the x-axis. And our bars will just look like this. Instead of vertical, they will be horizontal. So pay attention to which axis they are telling us to put each one on. So for part B, determine the range of number of bananas between 2010 and 2015. So 2010 is here and 2015 is here. So the range of bananas, right? Your range is your largest minus your smallest. Now, what is the largest number between this period? Largest production of bananas. What's the largest, Jewel?
2011.
What's that?
2011.
The largest production of bananas is in the year 2011, but
2011, 275.
275. So remember, we take our number, but we match it back to the amount. So the largest was 275. Determine the range of the numbers of bananas produced. Production. So 275 minus the smallest number produced is
14.
And therefore our range is what's our range? 235 tons. Yeah, any questions here? And this is how the range is for any question. If they ask you to find the range of values, you just subtract the smallest from the largest. Part C. During which year was there the greatest? What's that?
Yesterday,
What is the range again? The general number.
Your largest value subtract your smallest value. All right. During which year was there the greatest production of bananas?
Yeah, 2011.
Now we could say 2011, nice. How was this information shown on the bar chart?
Is tallest.
Correct. 2011 represented the tallest. 2011's production this is represented by the tallest bar on the graph. Yeah, nice. Between which two consecutive years was there the greatest change in the production of bananas? So what does consecutive mean?
One after the other.
One after the next. So two immediately following, one immediately following the next. So between 2010, 11, 11 and 12, 12 and 13, 13 and 14, 14 and 15. So in order for us to be able to see this properly, we record the change in each year. So what was the increase from 2010 to 2011?
125.
125, and then we do it for all. What about this one, the other one? So 125, what is the change between? $275.
Negative 175.
So we subtracted 175 because it went down. All right.
Subtract.
Negative 60.
Negative 60, we went down. Good afternoon. It's so long to work out some addition and subtraction, eh? How much? What's next, y'all? What's the next?
85.
Thank you. 85, then what's next?
125.
I do think so. What's next?
85 as well.
85. Right, so between which two consecutive years was there the greatest change in the production of bananas?
And 2012.
2011 and 2012, was that the greatest changes? It went down.
2010.
It went down 60. Huh?
Oh, but it changed, but negatively.
What's that?
Was a great change or a negative change?
Was that the greatest change?
No.
Was the CS the greatest change? So they were changing, but each year changed, but they didn't actually change. They actually greatest changes. So which two consecutive years represented the greatest changes?
So 2010 and 2011.
2010 and 2011, because we increased by the most, and then we decreased by the most consecutively. So between 2010 and 2011 represented the years with the greatest change. Everybody got that? No feedback whatsoever. Whatsoever. Everybody understand that?
Yes.
All
Yes,
right.
Max.
How is this information shown on the bar chart now?
Because 2011 higher than 2010.
So, no. So remember, you're not comparing the two. They're asking how is that how the greatest change between 2010 and 2011 is now represented on the graph.
It shows that it had a production of 125 bananas more than 2010.
It shows that.
It shows that it had an increase of 125 bananas more than 2010.
So it shows actually that from 2010 to 2011, that it really pitched up. And then from 2011 to 2012, it went all the way back down. So we see between 2010 and 2011, that was the greatest changes, because from 2010 to 2011, that was the highest increase. And then from 2011 to 2012, it was the lowest increase, the lowest decrease. So seeing that? So this information is represented by the difference in the heights between the respective years compared to all the other bar charts. So we see, if we look at the others, there's no other graph that had an increase like 2010 to 2011. If we look at 2012, it went down 2 centimeters and 2 blocks. If we look at 2013 to 14, we just went up by 3 and some. 14 to 15, we went up by 3. From 2012 to 2013, we went down 2 and some, right? But from 2010 to 2011, we went up 1, 2, 3, 4, 5. And then from 2011 to 2012, we went down 1, 2, 3, 4, 5, 6, 7. So now this information is represented by showing the largest change in the bar charts with regards to increasing and decreasing from 2010 to 2011. Everybody's understanding what I'm saying there, what I said there? Anyone understands what I said there?
Yeah.
So why aren't you responding on a well-recorded class? Because I'm talking to myself. All right. So this is represented by the largest increase, or let me say the largest change in height, the largest change in height between 2010 and 2011, and the largest decrease in heights from 2011 to 2012. And that represents that 2010 and 2011 had the largest increase and decrease consecutively. And let's go down. Give one reason why the bar chart is unsuitable for predicting the number of bananas produced in 2016. Anybody knows what can we predict what will happen to the amount of bananas in 2016? How the tons will be?
Miss, can you repeat the question, please?
The question says, give one reason why the bar chart is unsuitable for predicting the number of bananas produced in 2016. So here, 2016, why the bar chart is unsuitable for telling us an average of what the amount of tons will be for production of bananas in 2016.
Because it has fluctuated.
Because it fluctuates. Well, yeah, something like that. So can we look at this graph and say, well, based on 2010 and 2011, did we think that after 2011, the sales would have gone down drastically like that in 2012? No. And then from 2012, went down more in 2013, and then shoots up in 2014 and 2016. Do you automatically think that, oh wow, well in 2016 it will go right back up to where it was in 2011? Can we say that? No, we don't know. The bar chart is not a method of predicting information, right? So that is definitely one of the reasons. Bar charts are not suitable for predicting the change in any variables over a period of years or over a period. Bar charts do not predict information. You can't watch a bar chart and say, okay, 2016, we're going all the way back up based on the patterns before. No, bar charts are used just to represent the information, but we can't use the information before to predict anything that is to come.
Yes, so if you had said, because the values are not, there is no pattern. If you had said that instead of the answer.
Well. You can say that as well.
Okay.
Yeah, bar charts is not a way of creating patterns and therefore making predictions. Correct, yeah? Now we are moving on to January 2020. Another statistic question. A group of 100 students, pay attention, they did tell us 100 students. A group of 100 students estimated the mass of a seed. The cumulative frequency curve below shows the results. So the mass in grams, aka the weight of a seed, right? So we have, remember, cumulative frequency. When you're plotting cumulative frequency, we plot the grams against the cumulative frequency, not the frequency, right? So using the cumulative frequency curve, estimate the median. What is the median again? What does median represent?
Half n,
The middle.
half by n plus 1.
So the middle, yeah, right? So the middle, so in order to find the middle now, we use the formula half by n plus 1. So that's going to be a half by 101, which is 50.5, right? That's our middle. So if we do, who can tell me what is the size of each small block within our 1 centimeter? What is the size of this? Each small block will be how much?
Two.
2, so we say it's increasing by 10, so we say 10 divided by 5 is 2. So every small block is 2, so we know how to count our stuff now. So 50.5 will be very, very close to 50 because 1 block is 2, so that means it's almost on 50, right? So we just go on our 50. And once it hits here, what do we do?
Go down.
Go down. Which block is it on? From watching where it hit the graph, is it on the first, second, third? Is it on 3 or is it after 3? The first block after 3.
The first block after 3.
The first block after 3. Nice. So we can see that, right? It's on the first block after 3. So therefore, how much is that? Now we need to figure out how much is 1 block on our x-axis. That will be how much?
3.2.
1 divided by 5.2. Correct? So what will be our answer? What will be our answer for this spot here? Seeing that it came down here. What's the median you all at that point?
Yeah.
Right, so once we got our answer from the 50.5, we carry it down and we get our mass, right? So 3.2 grams when we go down. Let's do another one. The upper quartile. So the median is a central tendency, right? As we would have spoken about, which is your mean, your median, your mode. Mean being your average, median being your middle, mode being your most frequent, right? Or most occurred. Now, we worked out the median just now. But once they start to ask about quartiles, we are doing measures of dispersion. And what we do is we separate our sample into quarters. So we have our stuff here. And if we separate it into quarters, you're going to have the middle. Sorry. If we're separating it into quarters, it's going to be from 0 to 100, right? The first thing you have to do is find the middle, which is your Q2, which is your median. Once you split your stuff in 2, you can split it in 4, right? So your Q2 is your median, right? Now, when you split the first half into 2, you have your Q1, which is your lower quartile. When you split the second into 2, you have your Q3, which is your upper quartile. So to find your median, you use a half by n plus 1. To find your upper quartile, you're going to use a quarter now, because remember it's the first quarter, a quarter by n plus 1. And to find the upper quartile, what would we use? Help me. Lower quartile is a quarter by n plus 1. Middle, median is a half by n plus 1. Upper would be what?
A third.
How you reach that third when we deal with quarters? Quarters. A third is 3. We're doing 4. So what will be the upper? A quarter, a half. What's next?
1.
A quarter, a half. What's next?
1.
A quarter, a half. What's next?
2.
Somebody said 2. Who said 2? Who said 2? Own it. Matthew, you said 2?
I wasn't listening.
He wasn't listening. Guys, if I'm separating stuff into 4 parts, the lower quartile is a quarter. That's how I work it out, a quarter. The median is a half. The upper quartile will be what?
He was using quarter.
What's that?
He was using quarters. How can you use a half for the median?
Because
He said he was using quarters, right?
right, and this is my question I'm asking now, how to write a half as quarters?
2 quarters.
Right, so that's a half, right? So nobody writes 2/4, right? We just write a half, but we know it's the same thing. So 2/4, what will be the next one?
3 quarters.
3/4.
3/4, wow, y'all. So y'all mean to tell me, y'all forgot a half is 2/4? Right, so I don't need to write 2/4 because I know 2/4 is a half. Yeah, so the formula is a quarter by n plus 1, a half by n plus 1, and 3/4 by n plus 1. That's how we work out our lower, median, and upper quartile. N plus 1. So we're good with the median. Lower quartile, a quarter by n plus 1, upper quartile, 3/4 by n plus 1. Interquartile now, not semi, interquartile range is your Q3 minus your Q1. And then your semi, what does semi mean? What does semi mean, people?
Half.
Half, correct. So semi means your interquartile divided by 2. your interquartile range divided by 2. So the same thing from above, Q3 minus Q1 divided by 2. So for our upper quartile, we're going to do the formula 3/4 by 101, 75.75. So we go to 75, where's 75, 72, 74, 75.75, that's really close to 76. So we just hit it on this line here. Right. Remember, all these things are estimates, right? So how much blocks is it after 4?
2,
2, so what will be our answer?
4.4 grams.
Very good, 4.4 grams. Any questions? Do we have any questions with this one? It's just like the median, right?
Yes.
And what about the semi-interquartile? Now, to find the semi-interquartile is 2 marks because why? We have the upper, so we need to find our lower. So how do we go about working out the semi-interquartile? What's the first thing we need to do?
Find the lower quartile.
So the first thing we need to do is find the interquartile, yeah? And the interquartile is your Q3 minus your Q1. We already have the Q3, so yes, we have to find the lower. So Q1 is now what? A quarter by 101 giving us 25.25. And how much did we get for our lower quartile? So when we go and match it back, we got 2.2. Therefore, our interquartile range is what? What is Q3?
4.4.
4.4 minus 2.2 is 2.2. And now how to find the semi-interquartile range? 2.2 divided by 2, which is 1.1. Do we have any questions here? All right, the number of students whose estimate is 2.8 grams or less, what does that mean? Where do we have to go? 2.8 grams or less. Where is that?
Block P43 and lower down.
Right,
Zero.
so 2.8 to be here, very good. So we go all the way up. Remember, you have to match it back to your graph. What line does it hit on? Right below 40, right? So how much is this point here?
38.
38, and therefore 38 is the answer for the number of students who are less. If it was 2.8 or more, what will you do with these numbers here? You'll figure it out as 38, but what do you do?
What's your answer? What's your question?
If it was 2.8 or more instead of less, what would we do?
Then from 2.8 till 10 and go up until 100.
So 2.8 to 10, but what we do is we do the same thing, we match it back, we match it back. We know it's 38 at 2.8, but how do we know what is our answer? What would it be?
100 subtract 38.
Very good, right? Because below would be from here is 0 to 38. But if you want more than, because this part of the graph represents more than 2.8, we say 100 minus the 38, yeah, which will give us about 62. So that would have been our answer. Anytime you want it or more, you go to the point and you subtract the total from your point here. If you want it or less, you just take the number, because from here to here represents 38. From up here now represents 100 minus this point here, whatever is below this point, which is 38. Yeah, but our answer is 38. 38 students. No. The number of students, yeah, 38. I don't know where I read a probability question, you know. No. Right, quickly use the cumulative frequency curve on page 18 to complete the table. So from 0 to 2, they had 20. So what we do is we find the frequency, the cumulative frequency at 0, then find it at 2, and then subtract it to find the frequency, because remember, the frequency is not the added up ones, where you add up all the frequencies. So from 0 to 2, erasing. From 0 to 2, they had 20. Let's see how they got that. So from 0 to 2, it stops here. So the frequency at 0 is 0. Then the frequency at 2 is 20. So 20 minus 0 is 20. That's how they got 20. Now they want 2 to 4. So it's going to be, look at the frequency at 2, then at 4, which is up right here. So how much would that be? 70 minus 20. So that frequency will be how much? How much would the frequency be here? How much would the frequency be at 2 to 4?
Mr. Can you repeat what you said before, please?
Thank you. So what we do is we go at the starting and the ending. It comes like our limits. So they want from 2 to 4, the frequency from 2 to 4. What we have is the cumulative frequency, meaning they are adding up. We don't want them to add up. We just want the regular frequency from 0 to 2. So what we do is we have to subtract the cumulative frequencies to get the frequency. So from 0 to 2, the frequency at 0 was 0. The cumulative frequency at 0 was 0. The cumulative frequency at 2 was 20. So to get the frequency, we subtract the 2. That's how we got 20 minus 0 is 20. From 2 to 4 now, we take the cumulative frequency at 2, which is 20, the cumulative frequency at 4, which is 70, and we subtract the 2. What is our frequency between 2 to 4?
50.
50. And what is our frequency from 4 to 6? What do we do? Take the frequency from 4, which is 70. Take the frequency from 6, which is, how much is that? It's on the
94.
How much?
Looking like 94.
Correct, 94. And how much is that?
And 4 is 70.
Yeah, so what's the frequency?
24.
24. And what we do is to make sure we are correct. Remember, when you add up your frequencies, what should be the total here in this question?
100.
100. Are we getting 100? 50 plus 24 plus 6 plus 1 plus 20. We're getting 101. So one of our stuff is a little off.
One was a little off.
So let's look at it again. So from 94 to 4 at 6.
It probably 92 or 90 something.
93.
91.
93. Because it's kind of in between 92 and 94. Yeah?
Okay. Yeah.
So we see that. Very good. Nice. This is how we observe. So you see how you can check back your answers as well to see if you're correct or if you're wrong, right? So this one would be 23. And now we are correct. Right? 23. Nice. And a student chosen at random. A student is chosen at random. Find the probability that the student estimated. Find the probability that the student estimated the mass to be greater than 6 grams. So if I pick a student at random, what is the probability that they would have estimated the mass of a gram to be greater than 6? What sections are we looking at? Greater than 6. What are the sections we're looking at here?
6 to 10.
6 to 10, correct. Because this one is greater than or equal to 6, but this one is greater than 6. So what are the numbers for greater than 6? How many of them were greater than 6?
7.
7, correct. These two, right? So 6 plus 1, which is 7 all over. Remember, the probabilities are fraction over
100.
100. So that's going to be 7 over 100. And that's the end of our question, you all. Not very bad of a topic, right?